Hello. In this video, we're going to look at some more counting questions. And here we're going to look at things that must be together. Let me read the question. How many arrangements of the word cat are there if the letters A and T must always be together? So we're taking our three letters, C-A-T, but we're making sure that A and T are always together. Now, I'd encourage you to pause the video and give this a try, see if you can write out all the different options and see what you come up with. All right, so obviously we start with C-A-T. Then we could have A-T-C. So C in the front, C in the back. Then we could have C-T-A. So the A and T are still together, but they're switched around. And I guess we could have T-A-C. So C in the back, but switch around the A and T. Now, I think that's all the options. So remember, if we have three letters, normally it would be 3 factorial, which equals 6. But now we have an answer of 4. Now, how do we go from 6 to 4? How do we modify our formula? This seems really weird, kind of tricky, because, I mean, 6 to 4, usually in the past we've been kind of like dividing by something. I don't know. I mean, 6 minus 2 is 4, but I don't know if that really, we've never even really done subtraction. I don't know if this makes sense. I'm not sure. So what I think we need is another example. How many arrangements of the word France are there if the letters A and E must always be together? Okay, so remember the normal version would be 6 factorial, which is 720. But now we have to have the A and E always together, so it's going to be less than 720. I'm not sure we'd be able to write them all out. This seems like a lot of examples. So what I would recommend for you guys, if you want to give this a try, why don't you consider the different cases? So if the A and E are together, we could think about it like this. We have a 6-letter word here. 1, 2, 3, 4, 5, 6. And we could start with the A and E like this. Let's say the A and E here. So it's like the A is first and the E is second. Well, that would give you 1A, 1E, and then there's 4 letters, 3 letters, 2, 1, right? This one starts off with F, R, N, or C. So that would be the case where it starts off with A and E. That's going to give you 24. And I guess you could also have the case where it starts off with 1, 2, 3, 4, 5, 6, where it goes E, then A. Because again, there the E and A are together. 1E, 1A, 4, 3, 2, 1. That's going to give you another 24. Now, another case would be the A and E are together, but they're maybe right here. A and E right there. And then you'd have 4, 3, 2, 1. That's going to be 24. So I'd encourage you to pause the video and see if you can look at all the different cases we'd have. The A and E have to be together, but you can, I think, write out at least all the cases. Each case you can figure out the amount, and then we can add up all the cases. So pause it and give it a try. All right, assuming you gave it a try, we could also have the case where, well, let's do this one over here. 1, 2, 3, 4, 5, 6. We could have E and then A. 1, 1, 4, 3, 2, 1. That's going to be 24. So it looks like each case is always going to be 24. So let's think about all the options, right? We could have 2 letters, then we could have A, E, and then 2 more letters. We could have 3 letters, then the A, and then the E. Or we're going to have all 4 letters, and then the A and the E at the back. So this will be 24, 24, 24. And over here we'd have the same thing, but where we have EA instead. So that's going to be 24, 24, 24. So we've got to add up all of these 24s. We've got 24, 24, 24, 24, 24, and 24, 24, 24, 24, 24. So that looks like a total of 10 24s. So 24 added together 10 times is 24 times 10. That's going to be 240. So we're thinking the answer is 240, but I mean, we should probably check this. So let's see if we can get a supercomputer to solve this. All right, so here we have an Excel file, and this has created all the different combinations that we could have. If you look here, we have like A, C, F, R, and E, or we have A, E, C, and R, F. And if the A and E are together, then we give it a 1 in that column. And if the A and E are not together, we give it a 0. So if you look in this example, they're not together, so it's a 0. Here they are together, so we give it a 1. And if we get Excel to count up all of these different options, well, we're going to get the following. $240. So according to Excel, if we counted up all the different options, and you can see here if I scroll down to the very bottom, there are a total of 720 different permutations of the 6 letters. And when we count all the ones that have an A and E, we get 240. So our answer was correct, and that's exciting. But unfortunately, the answer we had required us to do 10 cases. And that's not really a formula as much as it is a supercharged version of writing everything out. So let's see if we can come up with a formula. So here's what we have again. We have the letters F, R, A, N, C, E. And we want A and E to always be together. So what I'm going to do is I'm going to take A and E and I'm going to glue them together into a super letter, AE. And what I'm going to do is consider now the letters AE, comma, F, comma, R, comma, N, and C. It's sort of like we have 5 letters, not 6, because one of the letters, well, 2 of the letters have now become 1 letter. These 2 got combined into the super letter AE. That way we know they're always together. Well, if we had 5 letters, then this would just be 5 factorial. And that would give us a number 120, which isn't quite our answer, but we're close. Our final answer is supposed to be 240. How can we get there? Well, when we had A and E glued together, we also could have glued it together as EA. And so there's actually 2 ways to glue it together, because if you have 2 letters and you're figuring out the ways to glue them together, the ways you could arrange 2 letters, that's going to be 2 factorial. So 2 factorial, which is just 2, times 5 factorial is going to give us 240. All right, there's our answer. And if we want to think about it with the blank method, this is how I like to do it. We have our blanks, and we know 2 of the letters have to be together. So I draw a little box to group them. Now inside there, because this is going to be either A or E, we have 2 options for the first and 1 for the second. Right? A can be in front or E, and then 1 after that. But now this box sort of works like its own blank, because the box could be anywhere in the row. It could be at the beginning, in the middle, at the end. Right? The A and E don't have to start off the word. So we draw a blank sort of over the whole box. And now if we look, we can just count down. We have 5, 4, 3, 2, 1. Multiply everything together, and that gives us 240. All right, so let's go ahead and try it again. We want to find out the number of arrangements of the word asteroid if the letters A and D must be together. So go ahead and pause the video and see what you come up with. All right, so we can count 1, 2, 3, 4, 5, 6, 7, 8. There's 8 letters, so I'll draw 8 blanks. Now A and D must be together, so I'm going to draw a little box there. This has to be A and D, 2, 1. Then we've got a big blank here, so this is 7, 6, 5, 4, 3, 2, 1. We multiply everything, and that's going to give us 10080. All right, let's try another one. How many arrangements of the word copyright are there if the letters CGP must always be together? So pause the video and give it a try. All right, well, we got 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're grouping 3 of them together. So this is C, G, and P. So it's going to be 3, 2, 1. Now we've got an extra blank here, and we can count. We've got 1, 2, 3, 4, 5, 6, 7 blanks. So this is going to be 7, 6, 5, 4, 3, 2, 1. Multiply everything together, and we should get 30240. Now again, if you're wondering why do I start at 7, right? There are, if you look here in our word, there's a total of 10 letters. 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, there's a total of 9 letters. So we take our 9 letters that we have, but we take the C and the G and the P and we glue them together into CPG, some super letter here. So really this is our first letter, and then we have after that O, Y, R, I, H, and T. 1, 2, 3, 4, 5, 6, 7. So here's our 7 letters. That's why we're starting with a 7 here, and then counting down because we're using every letter. How many ways are there to rearrange the letters in the word planet if the consonants must be together and the vowels must be together? Ooh, pause the video and give this a try. All right, so vowels are A, E, I, O, and U. So in case you forgot, vowels are A, E, I, O, and U. We don't say sometimes Y because it's math class. You can't have a sometimes going on. So Y is not considered a vowel. Everything else is a consonant. So we've got 6 letters, 1, 2, 3, 4, 5, 6. The 2 vowels, A and E, must be together. So we'll draw a box around them. And the 4 consonants must be together, so we'll draw a box around them. P, L, N, and T. So the A and E is 2 options, then 1 option. 4, 3, 2, 1 for the consonants. And then we've almost got here like the 2 super letters have become 2 blanks, so 2 and 1. So we have to multiply everything there together. 2 times 1, and then 2 times 1, and then 4 times 3 times 2 times 1. It's going to give you a total of 96. All right, let's go ahead and take some notes on this. I would call this the technique of always together. So whenever you have a situation where you need to have everything together, you could, of course, look at cases like we had at the beginning, but it's better to think about it in terms of grouping them with the blank method. The first thing we did with that France example was sort of just to motivate it. Once we're actually solving these, we just draw boxes and group them. So the idea here is if, let's say, 2 or 3 objects are together, draw a box around those blanks, and then count like normal. So it's really the same as the blank method, just with this extra step of drawing a box around the objects that need to be grouped together, or the blanks that need to be grouped together. So let me give you an interesting example. Let's say we have 4 science books and 3 English books, and we're going to arrange them on a bookshelf. Okay, so these are going to go on a bookshelf. But we want, and of course they're all different. These are 4 different science books and 3 different English books. And we want them to be organized on the bookshelf such that each subject stays together. For whatever reason, we don't want our English books mixing with our science books. We want English in one section and science in the other. How many ways are there to do this? So go ahead and pause the video and give that a try. All right, so we have 7 books, so we'll draw 7 blanks. The 3 English books have to be together, so we'll draw a blank around the 3. The 4 science have to be together. So this is 3, 2, 1. This is 4, 3, 2, 1. And then because we have the 2 big blanks here, this is 2 and 1. So we multiply this all together, and we get a total of 288. Now for more practice, you should add an example from worksheet 5 or 5.5. And some things to remember. I would definitely say that when you are drawing the blanks, you should remember to put extra blank above the grouping. In other words, above the box. All right, hopefully you enjoyed this video, and as always, thanks for watching.